Well, g'day, Max here again. Welcome back to the shop. So today we've got something a bit different. We've got what's actually a kit from D. Gray Drafting and Design, and it's a set of plans and the materials to make like a set of can't twist style clamps. Something I've wanted for a fair while to give them a go. So we'll come down and have a look, see what we got. So what I have here is a kit sent over to me from D. Gray Drafting and Design. So I believe he does a few different sorts of model engineering type kits, and he provides, you can buy either just the plans, I believe, or like this, all the materials included. So he very kindly sent me this one over to have a crack on. So we will do exactly that. So yeah, D. Gray, look him up. You might have something on in his range that interests you. So it comes with a pretty comprehensive, appear to be quite easy to follow plans, parts lists, breakdown, and if you're a little on the inexperienced side, at the back it gives you a few guidelines as well, how to do it, how to carry out some of the machining. So let's make a start. So just having a quick perusal through it all of the side plates been quite neatly laser cut out, and they're also laser etched in the positions where their holes need to go in. So that saves a lot of mucking around, makes it really easy. So you could just clamp all four together. Everything's pre-marked, and drill all your locations. That way you're going to have a clamp that works in a straight line, not a wonky line. So that's a good thing. I was just looking at the threaded shaft, which is the main piece there, and on the drawing it's dimensioned, this is all dimensioned in metric. So they're calling out M10 by 1.5 thread. So the stock is 3/8. So I'm just going to change the thread to 3/8 UNC. So I was about to change the dies over in my thread cutting die to 10mm, but as I've just been cutting 3/8 UNC with the Coventry die head, don't have to do it. So we'll use the die head. And I think we'll do this part first because I've already got the die head set up in the lathe. So yeah, we need to put some 3/8 UNC threads on this rod, and a lot of it. So using the material supplied in the kit, which is this piece of 3/8 diameter bar, we are going to make this, or two of these screws. So first up, we'll do the features on the end. So it's a piece parallel turned down with a thread tapped up inside. So we'll do that on either end first. Then we'll cut the thread using the Coventry die head. So we'll cut the thread on them both. And then there's a little hole, which is this hole here. So then we'll put the hole in on either one. And finally we'll cut it in half. The reason why I'm making them back to back like this is it makes it much easier to hang on to when I cut the thread with the die head. If I was just going to single point them in the lathe, I'd probably still do it the same way. It just gives you that bit of extra material to hang on to. Right, that's the tapping done. So now we've got to turn the end of the bar down. I think it's 8mm for a length of 15mm. And yes, you did see me hold a tap in air and run it with a spring center. Although not recommended practice, I'll still have to make a set of cone adapters for my small taps, which I don't have because I do bugger all small tapping. So you just got to be careful when you go in, that's all. You still get a true running thread. But yeah, it's the best way is a cone, reverse cone on your tap, and just use a small tap handle to rotate the tap. Right, let's get this parallel section turned down. So that's 8.36. Uh, 0.2 to go. Point 0.01 up. We'll let that go because we don't know. This fits into a reamed hole on another part, and we don't know what. We haven't made that part yet, so we'll just leave that 0.1 up for a test fit. completed thread. Nice, tight, neat fit. Well, that makes life very easy when you have these style of die heads. So we have 2 holes to drill in here now, and then we can cut the thing in half, and that's this part complete. Well, here's our 2 screws, so these form this part here. Now, before we make the T-handle, we need to just pull up stumps for a sec, because there's one very important job which we need to take care of. So we're going to do that before we do this T-handle. So this diversion consists of our, what do you call those fucking things? Tap doodad. So this quick diversion, I'm just going to have a quick doodle around with my cheap ass tapping thing. Fuck, got memory blank. So this diversion consists of a bit of a modification to our spring-loaded tap guide. So this is a non-expensive one. It's a cheap and cheerful thing. Wasn't expensive at all. It's quite piss wobbly, the fit, and it's piss wobbly because we'll call that the guide is a really slack fit in the body. Like you could drive a double-decker bus between them. And as we've probably got a few holes to tap, and someone's going to bag me out for holding the tap in a bloody tap wrench with one of these pushing on its ass. So let's find some material and we'll make a new plunger. So we'll make a plunger that has a point on one end and a tapered hole on the other to accept the tap. Bear in mind this tap has not got much of a, hasn't got a point. It's got a little chamfer there, so we'll make it so it accepts that. And then it's done. We're going to use a piece of this material here, which is drill rod, if you're in the above the equator, I guess, and for us down under it's called silver steel. So we're going to make it out of silver steel, and this is a hardenable steel, so you can just heat it up and throw it in a bit of oil and she'll harden up. But for this application, in its plain form is fine. Well, that's that sorted out. Made another plunger. So this has a recess in it. I can also turn it around because it's got a point on the other end. Spring, grub screw. So, because this tap has it's only a very shallow chamfer on it, but she'll fit in there. I do have a bigger one. I've got to modify that as well. But for now, this will get us out of the poo. The next part we're going to make is this sliding T-handle. So that's the screws we've made. And it'll be a T-handle for tightening up the clamp. So this is the material supplied, and we'll get 2 of them out of this. So we have to cut these off to 85 millimeters. It's 4.76 millimeter diameter. I guess that's probably started life as an imperial size. And then we also have this piece of brass. Whoops, just drop it. To machine these 2 parts here, which will be the end collars. So it's just a matter of, we'll just part this off in half. And with the end collars, they show them, looks like they're drilled all the way through. It's not actually marked on the drawing. So we're going to drill them. We'll see if I got a slot drill or something. And we'll drill them, we might drill them like a cup. That way we can sit the rod in them and run a bit of silver solder around them. We might go that way. So we'll part these off in the lathe, and for the parting operation, rather than go with my standard ISCAR tool, I ground up a piece of high-speed steel, and we'll give this a crack. Now, speaking of parting tools, actually before we get into the parting tool, My friend Rob over in the United States, that's his channel, Dudley Toolright. He sent me over a good tooling package, a mixed batch of tools, which really has got me out the shit on a couple of occasions. And there was also this box of new old stock Chicago Latrobe 1/2-inch tool steel. So that's what we've ground. I've just knocked this up this morning, and we'll use this as our cut-off tool. So back several years ago, in 2016, April 2016, I shagged my other parting blade. So I had to get a new parting blade, and you might be able to read this, it's pretty grubby. This is an S-Car Tang Grip blade. It has these L-shaped inserts, and this is what I've used ever since. I've never ever used that end yet. It's always been this edge here since 2016. Now, I get a lot of questions why I run this upside down. Well, in my lathe, there's been a couple of issues where I've had, little bits of chatter and that sort of thing. Now, bear in mind, I part off a lot of heat-treated steel, hardened steel, chrome, induction hardened chrome bar, and all sorts of things, which most people would struggle to get through, unless you're in the know and you know what you're doing. So running this tool upside down, I can put immense pressure on my cross slide to get this tool to dig in to induction hardened material. This includes hardened earth moving pins and all sorts. Now we're still on our first side of the blade. So funnily enough, I'll zoom you in. I do need to get another packet of inserts. So yeah, I got quite a surprise when I looked at the date and the price, $165 oh, excuse me, for a 10 pack of the inserts and the blade. So these inserts are that good. So from 2016, I've lost one insert. There's still 2 brand new ones. There's 3 in there, 6, 8. Oh, sorry, 6 is 8, 1 in the tool and 1 missing. This is the original packet. I still have 2 brand new ones in there. So in all that time, we've been lucky. With all the hard steel we've been dealing with, we've never ever broken an insert. This one here, it's worn on the edge. So I've been wearing them out. I don't break them. So that's when you buy top of the wazzer parting blades. That's the life you should expect to get out of them. Run them with flood coolant, and you'll get exceptional life out of them. So we want to cut this off at 85mm. Mind you, I have broken a few parting tool blades back in, well, I think it was 1980. I'll never forget it. I broke the end off a brand new S-Car parting blade. We should probably have that a bit closer to the chuck. Let's go in a bit further. Being how it's such small material. Broken a few of the old brazed carbide ones too, ones we used to use before the insert ones, the old carbaloy ones. They used to come in at a, I don't know if it was a 45-degree angle, fairly steep angle they used to come in. They're a special animal, those ones. They were good bars in their day. Bloody too busy yapping. Right, 85.5 is our size. Right, let's chop this. Right, we'll just break the edges with a file. Okay, there's our two pieces, so let's go. Make sure this is, yeah, that's all right, same length. Right, we'll do our brass cups. So 9mm these are ish. .02. That's fine. I'm not going to worry about .02 on a handle knob. We need to machine a little counterbore in there to accept our rod. So that was my new metric micrometer that was very generously sent over with some milling cutters by another viewer, Randy, so thank you so much. And it's like a new, you know, it's in new condition. It's a old box, like it's not a brand new, well it's might as well be brand new, the condition that it's in. It's got microns on it as well, which my old one doesn't have. So yeah, thank you so much, Randy. And he also sent over a few profile milling cutters. Let's have a look. Yeah, so a handful of cutters, radius cutters, 45, keyway cutter, side and face, slitting saw, about a 30-degree or something, with a radius on the edge. Some radius cutters. So yeah, we'll other radius the other way. We'll have some interesting milling when we go to use these, and also he threw in a couple of end mills as well. So thank you very much. So we'll use a slot drill and we'll counter bore in 6mm. That'll leave 1mm on the rear of the wall. So we need 4 of these in total, so I'll do the other 2 off camera and bring you back. I already have some little offcuts of silver solder sitting in the cup, so it just makes it a bit easier when we don't have three hands. And also a little bit of flux in there as well. There it goes. That's our silver solder joint. So I'll let these cool off and I'll just clean this up, and then we can insert those into the threaded rod and silver solder the caps on the opposite end. Okay, so these came up okay. Just give them a quick tizzy up on the Scotch-Brite wheel. So, little gap in that one, but it's just a bit of an estimation how much silver solder I drop in the cup, because like I say, if I had three hands I could feed a little bit extra in if required, but don't have three arms. So what we've got to try and do now is repeat the process with the screw. Now this one here actually needs a tad more I think we'll quit while we're ahead there. Okay, that's that one. Now the next one. That's looking good. Okay, we'll get this cleaned up when it cools off and we'll have a look. So the silver solder I was using then was the Pro Silver 45T BOC and Easy Flow flux paste. So this paste, it's like very moist. It's not a dry one. We used to just add, I think we used to add drops of water to it when it needed to be a bit more runny. So that's our completed handles as per the picture, the drawing. So they worked out very well. It did work out good making the brass ends into a cup, and I was able to just cut off some small bits of silver solder and drop in the cup with some flux, and as you've seen, just heated it up and until it all bonded. Alright, we're running out of time here. I probably could have got another couple of parts made if I wasn't waffling so much. So we're going to run into part 2 on this series. So part 2, we will get it complete. A little bit of a delay on this video. I'll show you why, because I got tied up with something else. Let's wander down the other end of the shop. So that should be a clue. The top of the DSG is looking very empty. And all of the JFM T-bits that were sitting on top of the DSG are now assembled up in here. So everything's inside. So we'll go through this the next video on the dramas and the ongoing dramas as we have to strip this down again. But that's another video after the D-grey clamps. So here there was some fun and games with that JFMT apron, but that's another video. Let's get these clamps knocked out first. So anyway, cheers, thanks for watching, and yeah, next time we'll knock this one off. So cheers.